Hi guys.
I
Hi
hope all of
guys.
you are doing good. You guys have had a
Hi.
perfect weekend, and also you guys are excited with these hands-on coding with Solidity. If you guys are probably joining this entire bootcamp, today being your first day, then this is actually the day 3. The first day, David, who's also doing this bootcamp with me, took the audience through what is blockchain and what really happens on the blockchain, the nitty-gritties about blockchain and smart contract. On day 2, I sort of introduced what Solidity is, what really happens inside the Solidity, the important data types, and how we essentially play around with that. We kind of went through a little bit on 1 or 2 smart contracts. We didn't dive deeper so much on as much as we needed to or we wanted to. And today we're going to dive into in Hardhat, right? So just sharing or running through some of the slides that we sort of went through on day 2. Today on day 3, we're going to be talking about Hardhat. These are some of the links that I had used in day 2 of my presentation. And now we're just going to focus on Hardhat. Just give me a minute, guys. I just need to quickly change my screen. I will request for a small pause. Yeah. Hi, guys. I'm back. Apologies for that small disturbance. Right. So as I mentioned, today we're going to work with Hardhat. And I'll obviously tell you what exactly Hardhat is and why this is one tool that most of the developers use, and are there other tools that we essentially use for smart contract development, so on and so forth. Right. Now, if essentially you've done development for quite some time, you already know what React is, right? React is basically a framework essentially that helps us in developing front end of various applications. Similar to that is Angular, similar to that are some other tools like Vue.js, so on and so forth. And the same analogy is Hardhat. Hardhat is a framework that essentially makes development of smart contracts, development of Web3 applications, specifically for EVM machines, way, way easier. Now, Hardhat has its own website. I'll quickly show you here, and has very detailed documentation. There are a lot of tutorials that are available. There are a lot of documentation guidance available. There's a big community around Hardhat, so obviously as you go along this particular procedure, even if you have questions, shoot them, and there will be a lot of help available. In terms of chronology of events, what really happened is the first tool that essentially came about in which helps in developers in sort of working with smart contracts was Truffle and Garage. And it's also one of the most famous tools. A lot of people actually start with that. And then Now Hardhat has taken over essentially, I think 70 to 80% of the code that is written in smart contract or Web3 application side uses Hardhat as framework. And a third one, which was introduced last year, is known as Foundry. It is also one of the most heavily used tools. It's sort of picking up a lot. And in fact, has gained a lot of popularity the last couple of 6 months. And as you obviously embark on this journey of developing smart contracts, developing front end, developing a lot of things around that back end, or I think you'll also realize that Foundry is a lot that has also been favored. We focus, as I mentioned, Hardhat because Hardhat is today the most used frameworks among all of three. Right. These are some of the advantages of Hardhat. Now, they are not unique, so much so all of them to Hardhat. In fact, Truffle was lagging on a few of them, but now they've caught up. Then there's Foundry again, which started out but didn't have all the features, but now it's trying to catch up, essentially. So, long story short, Hardhat does have its own edge, but as each every day happens to grow, the level playing field is coming along. So you'll either have with Hardhat similar options or with Foundry through some other libraries. Now, Hardhat is simple, and I'm going to sort of play around with that a little bit. And we'll also then talk you about through a couple of repositories that you can play with, right? And we are not going to there's obviously a repository that you've already prepared. You can just fork it and then continue running through some of these scripts that you mentioned. Right. So I'm going to quickly dive into my VS Code. I'm going to just basically work on changing the screen and sharing my VS Code. But in the meantime, while I dive into that, what I'll need from you guys is a little bit of help. I need you to basically, in the chat message, in the comment section, just basically drop me a thumbs up if you're ready with, joining this call from a computer and you have VS Code and Node.js installed so that we can sort of dive down into what we're trying to do today. Hi, guys. Right. Uh, Yeah. So Aditya is just a sort of comment, which says he's not joined the last session. What should I do? You should continue with this one. There are links, which means there is some sort of linkage between this and the last few ones, but don't worry. Everything that you would over here is still a walkthrough. And in fact, the early two sessions were a lot of on the theoretical side. This one's really on the practical side, very hands-on practical work procedure involved today. So just go ahead, follow the procedure, and you'll still be able to catch up on a lot of things. And then obviously you can go back and look at the earlier sessions and sort of catch up on the theoretical part. Right. Cool. I'll just wait for 2 more minutes and then we'll sort of jump into the coding part. What I've done right now, obviously, as you'll see on my screen, is just basically open VS Code, and I've just kind of routed into my folder that I've created for Devsnest training. Usually there's nothing inside the folder, it's just an empty one. And so we're just going to basically go ahead and sort of install Hardhat with this one and then sort of go from there. Awesome. Right. Okay. So what we're going to do is just basically create a folder, obviously use a terminal to reach that folder. And we're going to use a command npx hardhat, right? npx is again a tool, which is basically like another library which you need to install, which basically just connects to the npm package and sort of runs the script. Once you run npx hardhat, you will be welcomed with this project. Sorry, the screen, and just questions, drops in a couple of questions. Do you want to create a JavaScript, TypeScript, or an empty hardhat config, or just quit? For simplicity purposes, I'm going to just go with the JavaScript project. And it'll obviously question me, where do you want to install? I'll say yes. And do you want to have git ignore? I will definitely say yes. Do you want to install the dependencies? Again, to that, it is a yes. And it'll basically create a very small project, again, like React or Express.js, honestly. Right? It'll just basically create a very simple project. And I will see the folders and the packages and all the dependencies that are required for the purpose of maneuvering through this particular basic repository and then playing around with that. Right. File disamples. I'm also looking at the comments. Shom's question is, are we going to use ethers.js or web3.js? Hardhat by definition use ethers.js in its internal dependencies. So we're going to use ethers.js. Today, we're going to play less around with, doing a lot of fancy things on ethers.js. Depending on how the training goes, we will be doing. But direct question to you is, it's mostly an ethers.js dependent project rather than web3.js. Having said that, Hardhat has its own plugin. So it has a lot of plugins that you can install. It has its own Web3.js plugin. If you're very comfortable with Web3.js, do not hesitate. You can just install a Web3 plugin. There's a lot of documentation around that. You can just play with Web3.js and use this entire project using Web3.js. Nothing complicated over there. Okay, so as you will notice, the installation has gone through. Obviously, I'm just getting a small notification saying that we have I need to update my npm, but really, obviously, that doesn't matter. The project is created. Quickly running down through the folders, what's going to happen is open a folder, which is fine. I'll just quickly select that thing. Code doesn't training. All right, this is what I want to open. That's not training. And open. Right. Cool. So once you open that particular project in your VS Code, or for that matter, if you have any other editor that you're using, just these warnings, you will basically be welcomed with a couple of folders. Contracts, obviously the smart contract folder, which you're going to play with, a script, which is in JavaScript, which is deploy.js, and test folder, which has, again, the test script, and a Hardhat config, right? Now, without going into too much of depth, what really is going to happen is that I'll take you through these files on a very high level basis, right? So that you have some grip on the very, very base level repository of how things work and all that thing. That gives you a little bit more confidence. Okay, how if I'm going to change a lot of things, going to play around with a lot of stuff, how is it going to happen, what's going to happen, and how will I be able to maneuver through this thing? All right. So just give me a second. Contract. Okay, I'll just zoom in so that you're able to look at this file more easily. Right. Perfect. Okay. Now, in my earlier session, that happened on day 2, right? I talked about pragma solidity, what this number is, but trying to quickly catch up over here. This is basically the compiler version. Solidity in itself is a high-level programming language, which has different compiler versions. But in the base case of, obviously, Hardhat, we are welcomed with a contract which uses 8.9. There are multiple versions, so you're free to sort of select your own, play around with that. And different versions, 0.7, 0.6, everything has a sort of a release document. You can obviously compare what are the changes across multiple versions. Now, this is a very standard contract, nothing so complicated in this contract. And I'll run through this contract real quick, and then we'll talk about it in depth as we play along or do the transaction, right? The contract has to start with the word contract. It's a keyword over here, and then the name of your particular contract, which I'm not going to go to the protocol that we follow for naming, but essentially is the first letter is always caps, right? I'm going to skip line number 8 to 11 right now, but I'll come to that in a minute. Constructor, right, is the function that really gets called when the contract is deployed. In this case, the constructor requires me to enter or provide a number. It's an unsigned integer, right? So I need to provide a number, and it is a payable function, which means when I deploy this smart contract, I need to transfer some value along with it at the time of deployment, right? Just to try to catch up from my previous discussion, essentially in blockchain, stuff needs to be paid for, even if you don't have functions which require you to transfer some native token of that blockchain. There is gas cost involved. Apart from that, some functions, when defined as payable, which means for this particular function to be run on the blockchain, I need to basically drop in actual native token. In the case of Ethereum, the native token is Ether. In the case of Polygon, the native token is Matic. So on and so forth. Multiple blockchains, different native tokens. What native tokens are and why they're required, again, something that we've covered in the presentation and the talk for day 1 and day 2. I really request you to go back if you need to catch up on that. The first particular requirement of this function to run is that the block timestamp must be less than the unlock timestamp. Now, what essentially it is that the blockchain has blocks, and every block has a timestamp. So in this particular case, we're saying that the timestamp of that block must be less than the unlock time. So in simple terms, when this contract is deployed, I'll say that I'm going to lock some money at the deployment of this contract, and that can only be unlocked in the future. So if I put dates to this, if I'm deploying it today, I'll say that the money should be unlocked on, let's say, the 30th of June or the 31st of December, and so on and so forth. If I were to put a date or a timestamp of, let's say, the 1st of February, the 1st of January 2023, it is going to fail this condition, and hence the deployment will fail. Then it just basically takes the value and stores it into the storage of the contract. It says unlock time, which is a parameter that was passed, and we had already created a contract storage variable, as you see it over here. It's an unsigned integer. It's a hardly strictly typed language. So unsigned integer, a public variable, which means anyone outside of the blockchain can just click a button and see what the unlock time is. And then it'll tell you what the unlock timestamp is. Then the last thing is that it sets another local, the contract storage variable of the name owner. So owner is a name. It's an address. It is public, which means anyone can see it. And it is payable for a particular reason. What I'm trying to define by this protocol or the Solidity compiler is that this particular address should be marked as payable, which means this this contract must note that it may be required to send some funds to this particular address sometime in the future. And because it is an address which may be required to receive funds through the contract, it is payable. If I were to, let's say, use the same line, but now I'm going to define as owner 1, and I remove the word payable, what's going to happen is that the transferring of some value or Ether native token from this contract to this particular new address, which is owner 1, will be an issue. It will cause some issue. Compiling issues are separate, but just at the time of transfer, there'll be some issues. I'll have to redefine this as a payable address. Right. Now, after this is done, we have two functions. Just one function, which is withdraw. By simple logic, you'll understand. I've deployed a contract, put in some money, and said that it's going to be locked for a couple of weeks or months or whatever it is. There has to be a withdraw function. By definition, again, standard points will go. The withdraw function will first check whether your block timestamp is higher than the unlock time or equal to. So if I say 30th of June, then when you're withdrawing, are you withdrawing on the 30th of June or later? Because otherwise, the funds have to be locked. The one who's actually triggering this message or calling this function has to be the same guy. Otherwise, obviously, anyone can steal my money. There are some events, and there is some. This is the transfer functionality. Now, this owner.transfer, and then this particular balance. Balance is the amount of the native token that I've just sent. As you can logically decipher, Address.this means the address of the contract and the balance, whatever money sitting inside the contract. This dot transfer will only get triggered if the account is payable. And that's the reason why, as you see, the owner is defined as a payable address over here. Now I'll come to the last thing over here, which is the event, which is defined over here before the constructor event. And then there's something known as emit. Now, obviously, emit is basically emitting an event or, sort of using or signaling something. And to signal that something, we must first define it. So we'll just go quickly to defining what this is. The keyword is event. And we're putting a name to it. And then we're putting certain parameters of what will we be emitting when a particular event takes place. Now here, we'll stick to very simple. The name is withdrawal. We're going to basically use some parameters, amount and when. And then I'll come to right over here. Whenever this function is getting called, the blockchain has something what they call the events emission, right? Every block will have that section, which a third party or basically libraries like React or other JS, other frameworks, through the use of Web3.js or Ethers.js, will be able to read the occurrence of an event and then be able to do whatever they need to do. So blockchain is basically just shouting out to the network saying that there has been an event, but I'm emitting. The name of the event is withdrawal. How much is the amount, which we already defined, and then we're saying when, which is what that timestamp is. Simple enough, not that complicated. That's what high level the contract is. There are some comments over here. I don't want to go really so much on the comments part. It's about console log, which we will come by the way, but I will for right now just hold up to that. Again, I'm just going to pause over here for a minute. If you have any questions, drop me, put in the comments, and I'm going to sort of address them before I go further into this. Cool. Okay. So I'm lucky that we do not have any questions till now, which means we'll dive into this exact stuff. Now, sorry, let me close the terminal so it doesn't confuse you. This is the standard contract. Now we need to, what really happens is that we're going to basically deploy it on a blockchain to be able to sort of play around with this thing. Now, before obviously going into the blockchain phase, we need our confidence level to go one notch higher, which means we're going to play around with some other stuff. There are some two folders, as you'll see, scripts and test. We'll go through the test before we go on to the scripts file. Test file basically writes the edge cases. So as you go into the development of smart contracts, you will understand that testing is very, very critical. I can't repeat that or can't emphasize enough. With Web3, testing is very, very critical, mostly because Web3 or blockchain are immutable, which creates a pain for us because if we deploy wrong contracts, there is no way for us to basically withdraw that contract or basically take it out. Some here and there, people will tell you that there are some hacky ways, for example, destroy a contract, self-destruct, or basically go for upgradable. But essentially, if you have deployed a code of smart contract at a particular address, it cannot just be vanished, right? Which basically has its own repercussions. So we're going to run the test file and then we'll sort of see the test passing through and then from there on, go for doing some other things. So just give me a minute. Right. Okay. What does this test really do, right? I'm not going to go through chai and mocha to explain the basics of it, but you already know. We're going to basically, we define a function which says, you basically putting a time period or calculating that what is the 1 year in seconds to determine a timestamp. And then you're just basically calculating the value or the amount of money that we want to lock. Right. The locked amount is 1 GUI. I don't want to go too much into what GUI and Ether is. Day one of the training already talked about that, so we can ignore that. And then we're defining what the unlock time is, which you've already seen over here. And then a couple of more basic stuff that we need to deploy contract. Again, Ethers comes over here. We'll talk about it in a minute, but essentially let's go dive into the testing file. Here, we first determine a test whether we are setting the correct unlock time. Again, nothing complicated. We just first taking the same unlock time. While at the time of deployment, we are basically passing that as parameter and then checking that the value that is stored inside the contract is the same one. So as you'll see, we are basically loading the deployment fixture, which is over here, right? With the unlock time, which is over here, unlock time, and then checking whether the same thing is correct. Because it's a public variable, we can just ask the blockchain what is the value of the unlock time. The next one is checking the ownership. And the last one, checking that we are able to withdraw the funds after the end of this thing. And then one more, which says that we will not be able to withdraw if the unlock time is still in the future. Could have got a lot of complicated tests that Hardhat has introduced. They were not earlier like that, but most of the stuff is simple. It's just checking for events, checking sort of transfers, so on and so forth. So I'm going to quickly now open my terminal and run through the test. To run the test, it's very simple. You're going to run npx hardhat test. Right. It's going to do is it's basically in or behind the curtains, create a mock blockchain, deploy this contract, literally call all of these functions as we have defined and test files to do, check the value against the expected, and give us the results. Right. So as you see, I have thankfully, pass all the tests because obviously I've not changed anything, and sort of gives me everything. It has been able to set the correct unlock time. I've checked the owner, whether it's the same owner or not. Most of the stuff you basically understand. It's sort of mostly driven, right? Now, what essentially happened over here is, I'll just quickly let you know here. Hardhat tries to run a blockchain, which you can also run by just saying npx hardhat node, right? In this case, a mock blockchain starts, and it starts with accounts, and all of these accounts have some native token value that has been given to it, because each of the accounts might have to either send ether or use it for its gas and so on and so forth. You can run the same command npx hardhat node, but with a couple of more modifications. Details of there are in the documentation of Hardhat, but as of now, we don't dive into so much complexity around that part, right? And now, if I have to run the same test in this particular blockchain, I'll just quickly open another terminal for me, right? And what I'm going to do is npx hardhat test, and then I'm going to say -- network local host, right? Now, as you'll see, what will happen is it'll basically do the same thing, but now all the transactions will pop up in this other terminal. These are all the blockchain transactions that literally happen right now. But this time I've provided, or I've told the command, I run the test, but not in the network that you run behind the curtains, but actually on the network that is running already on the local host. And Hardhat sort of takes care of it. Obviously, all tests pass, and these are all the transactions. Just quickly showing you something over here, which might be of interest to you, and you will come across as you sort of progress on this career. This particular transaction failed, as you'll see, lock withdraw. You basically called the withdraw function inside the lock contract, and it failed. And it failed for a particular reason, which is reverted with reason string, you aren't the owner. The interesting part is, if this transaction failed, then why, as in my test, showed a particular failure? And that's the reason is that we've literally defined the test, expecting it to revert with the exact definition of what the error will be. Should revert with the right error if called too soon, should revert with the right error if called from another account. Now, if I go and check this one, which is should revert because the owner is different, just quickly show it over here, should revert right, which is right away. As you'll see, the error that I was expecting is you aren't the owner. And the error that literally the blockchain threw was you aren't the owner. To test this, or to sort of, obviously, you should figure out some mistakes. I'm just going to change this and say that the error that I'm expecting is not you are the owner, but I'm doing a typo. I'm basically removing the word last letter R. And if I run this particular test, and again, a basic tip, if you really need only one test to run, just put dot only against the it file, or sorry, it keyword, and it will only run that particular test. So I'm running that very particular test only, and just quickly, yeah. Now I did see that my test script is telling me that your particular test failed. As you see, it says 1 failing, 0 passing. I just ran only one test, right? And the reason my test script says the expected transaction to be reverted with you aren't the only, or whatever, how you want to pronounce it. But the actual result was you are the owner, and that's error. It's not the same thing. And hence my test script showed that your test is failed. But on the blockchain side, essentially, that's the only thing happened. The script failed with the keyword you aren't the owner. And where is this you aren't the owner? This is exactly in the lock.sol file. So quickly showing you here. The withdraw function requires that only the owner can basically call this. If it fails, throw an error, you aren't the owner. And that's what is happened. So I've completed the loop for you. The test file where it sort of changed this thing, made it fail, and expecting how to play around with the failures. Going to pause over here quickly and throw in your questions so that we can then proceed to a little bit on the next level. In the meantime, I have something from an account, Gaming Theory. Assume that's supposed to be Gaming Theory. What about proxy contracts? Okay. So proxy contracts is a little bit of advanced topic. As of now, I think it's just progressing slowly towards it. We will hopefully be covering proxy contract. But essentially what proxy contracts are, as the name suggests, they are just proxies for some other contracts. And how this works is, I will deploy a contract and say that whatever call is made to me as a smart contract, do not execute. I don't have the code for it. I'm just a proxy. So I'm basically just locking an address for someone. Take the same function and give it to someone else, right? Which is what we call the implementation. And that's how proxy or upgradable contracts are defined. So no contracts are upgradable. What you define is you place in a contract with the word, the proxy in definition, and there are multiple types of proxies, by the way. And then this proxy contract will all take the calls that come into it and just pass it to what's called the implementation contract. The implementation is the logic. And if you want to upgrade your contract, you just basically deploy another implementation contract, go to the proxy and call the function, change the address to which you want to pass the function, or the implementation contract is now this new one. And that's how it works. A couple of years back, you had to manually deploy a proxy contract, then manually deploy your the implementation contracts, connect them. Now it's very standard and simple. There are a lot of libraries or plugins. Just attach them with your Hardhat, and it just works out of the box. You don't have to go through. You just have to figure out, or maybe just Google how to deploy upgradable contracts using Hardhat. That's a nice topic also. Maybe we can do a tutorial around that in our blog post, and then we can share across the link within the Devsnest community, and then you can possibly jump on it after that. Okay. So no questions on it yet. Also no other questions. So what I'm going to do is proceed further. I'm going to just kill this blockchain that I was running on the side, clear my terminal, and now I'm going to go through the deploy script, which is in the scripts folder, which is deploy.js. Deploy script, name already, or gives you the hint. A script will basically just deploy the smart contract, and it will not do anything else, right? Is a portion of the deploy script is also a part of our test file already. And if you can think, I can extract something from the test file and create a deploy script, right? Now, deploy script basically, now HRE, or what we call the Hardhat runtime environment, or also you can say the entire framework, has a lot of helpers, or makes it easier for us. Ethers has what they call the get contract, and HRE basically sort of attaches to that, and you can play it out with this thing. Before Hardhat, and honestly, sometime before even Truffle and found Truffle, unfortunately, we had to go through manually importing the contract, the API, and byte code and play around with it. But now you don't have to. You just have to use the same word as your contract is. So here we're saying that create a contract factory with the key contract or the contract with the name lock, and then just deploy it. Obviously, the deployment requires me to pass parameter, which is the unlock time. So basically saying this is the unlock time, which is basically current timestamp, and then convert it to 1 seconds. And it's a payable function, so I have to also send in some money. And here is a defined value over here. That's it. And we just have to await. This particular line is to make sure that we wait till the contract or the transaction is basically processed. So we wait for that, and then just console logging that it has been deployed. And that's the end of the script. So I'm going to quickly run the same local blockchain to show you how it works. npx hardhat node. Right. Again, a simple blockchain has been started with 20 accounts, and each of them having 1,000 ethers. To make it more sort of let you have a little bit more grip on this one, nitty-gritty, is what I'm going to do is, okay, right. I'm going to just play around with something so that you have it a little bit more. The first thing I'm going to do is copy this value, which is get signers. Now, what a get signers is basically these unlocked accounts. Don't have to stress too much around it. As such, you have a lot of standard scripts that you can use, so don't waste too much of time around that. But in the mainnet, you don't have what they call the get signers. It's only this test blockchain. You have something what you call the test this thing. So I am removing everything else. I'm just saying owner. The deploy keyword basically uses the first unlocked account available on the blockchain. In this case, the owner account itself. And that's the reason why we didn't have to. But if you had to, then you had to just basically, let's say, go here and say account 2. And then I would just say, right, dot connect. And then come over here and say account 2. This will basically deploy the contract from the other account. But right now, not going to do that. And to make it more simpler, I'm going to console log 2 values. Yeah, not owner dot address, owner dot, does it have balance? No, it doesn't have. Okay, Jari dot ethers dot get balance. Yeah, I would have loved to do that, but now that Copilot exists, console log the owners. Okay, the owner balance. Yeah, I know that. Come on. Okay, I will have to go check the keyword over there, but you will have to maybe do it, unfortunately, on your own. Essentially, what I wanted to show is that the balance of the owner account is sort of reduces because of the 1 ether that we're trying to send, and also the gas fee that we're going to send. But anyways, right now, let's just keep it outside and just run through the normal script. You will just see one transaction, which will basically be the deployment of the transaction, deployment of the smart contract. Yeah. Clear. For this one, we're going to do npx hardhat run scripts deploy JS -- network, because I want to do one of my local hosts. Otherwise, it'll again go back to the behind the curve of this thing. That's it. As you'll see, there's only one transaction, which is your lock has been deployed. Contract deployment with the word lock, and that's the contract address. Transaction hash from and so on. So we'll keep it outside as of now. And if I check my console log of the address, it's exactly the same as which is over here. Right. So again. Okay, cool. Okay, so I'll pause over here. We've gone through the basic script. We've also gone through the testing. We've also gone through the deployment of on the Hardhat node, which is a very simple task to do. We haven't done any change mostly in the entire code base. And we can play around with a couple of things if you want to, but run through the very normal stuff. And then from here on, we'll be doing a little bit more complicated stuff, so on and so forth. But essentially, going to pause over here for the questions. So I see a question which is game theory, which why do certain functions show infinite gas? Okay. Well, okay. Any function which has infinite gas will basically not get processed by the blockchain itself, because every block has a finite amount of gas that it can consume, you can think about. Or sort of all the transactions together can basically use up. And thus an infinite for loop will basically just crash because there's only so much gas available to us when we are creating or calling functions. So if a function particularly shows infinite, then you will have remix on some other frameworks and scripts show you an error, but it will be a failed transaction because it'll never go through the entire loop. So there's no such thing as infinite or infinite loop, unfortunately, in the blockchain case. Okay, so I do not have any further questions over here. Right. Okay. So today I'm going to, let me just close this blockchain. Okay. Clear. Right. Now, what we're going to do, I'm not going to make it, again, we have, in the presentation, we have links to a tutorial repository, which has more complicated. I'll quickly just show that to you so that that's completely not alien when you go that. But we'll covering that in a session that we will be doing tomorrow, right? Again, links of this is also inside our presentation. I will talk about it tomorrow as well. Feel free to join. We've written a lot about this thing, so on and so forth, right? And there are a lot of complicated contracts over here, which you're free to play around with, or we will go through it tomorrow. Now, typically when you write contracts, they are either highly complicated, which you'll see a couple of them, which imports another contract and sort of has a lot of function. And your test files are again complicated a lot, which we'll again go through them tomorrow. But one of the most important files is your config file, which is over here, hardhat config.js. I'll go through each of them and sort of talk about every single one of them. But in this networks tab is something which is important, which you'll see as in my current network.js, in my current standard plain vanilla hardhat config or sort of hardhat thing base repo. There's no such thing as networks. But once you go into sort of progress on this one, network becomes important. Network is the place in which you can ask or sort of configure your hardware project to talk to different blockchains, right? The Ethereum mainnet is one blockchain. Ethereum has multiple testnets, which are again Nicorelli or Sepolia, so on and so forth. And then there are other blockchains, like for example, Polygon, Avalanche, so much others, right? As you'll probably be on your day 2, day 3 of your self-coding on this one, you'll realize that everything locally is good and fine, but I now need to deploy my contracts on a real blockchain to be able to test how things are going. And at that stage, you will find that I need a testnet. You can't go on a mainnet because everything on the mainnet is associated with real money, right? You'll have to buy the native token Ether that has its own value. If you are playing with the ERC20 contract, they have its own value, so on and so forth. So you need to have a testnet. To make it easier, what we have is the product that obviously I'm working on right now, which is Billware. Once you go onto the Billware website and you sign up on that, what you have is the ability for you to create your testnet, create your private testnet or a sandbox. We basically just help you use some of these mainnets as your own testnet. You'll just either do a launch app, and basically, if you're doing it for the first time, it'll take you through a particular form, which you need to just basically fill in just to say where you heard the website from and what do you do essentially. It's just a 3-4 question form, very simple to do. Then you will be landing onto something which will say create your testnet. In my case, since I have already created a testnet, it just shows up the name. But if it does not, what you will see is create a testnet, and then if you click that thing, it'll ask you some questions. For the purpose of this testing, or generally on Buildbear, each of them is just a testnet. So you're free to fork any of the existing chains or just use with none, your choice, no problem. You can create a Ethereum 4, Polygon 4, whatever you feel comfortable with. And whatever button you select or chain you select, some details will pop up. You just have to say next, and you will basically be shown some information. Do not worry about anything. Just click the create build by testnet, and what you will land up to is basically something like this. Here, the only thing which is the two things which are somewhere critical to you are this. Either you will basically use mnemonic. In this case, what I'm assuming is that you do not have MetaMask installed, or for that matter, you do not want to use them. But if you do, then this is what you're going to do. Just basically click the add to MetaMask button, and it'll basically add this network to your MetaMask. Open the faucet, and then basically just connect your wallet again, and you will be able to mint subnative tokens to your address. Why do you need that? Because you need to now, you're going to use this particular address to be able to deploy your smart contract, or this particular address to basically play around with test files on a public testnet. The other option is basically just go over here and copy the mnemonic. That's another simpler option. If you copy the mnemonic, it's going to basically do some stuff. So what I'm going to do is just completing the loop over here. I'm going to create in my standard this thing, a new object with the name networks, and define the test network. In this case, I'm just going to say Buildbear, and then it'll need an RPC. This RPC is what you would see, what Buildbear already provides. I'm just going to copy that and paste it. Right, this is my RPC, and then go with accounts. Okay, essentially that's strange. Okay, just change that. Yep. Essentially, that's what I thought, but why is it not on? No. That's what I thought. Okay. IDO. Okay. I am going to go to my accounts, copy the mark, and paste it over here. Now, what's happening is that the unlocked accounts or ethers.get signers will be basically driven with this particular mnemonic and not just the standard one that Hardhat has created. These are specific and unique to your private testnet, so you just have to copy them. In this case, I don't have to basically use the private key of my MetaMask. I do not need to fund it. There, obviously, these mnemonic accounts are also funded, right? Now, what I'm going to do is, I made a mistake over here. Quickly taking this one and going to the standard one that I was actually working on. Yeah. Now, if I run the same test file or deployment file, but this time using the network with Buildbear, it's going to do that. And you'll basically quickly see them. Okay, there's all my errors. Yeah, right. I think I need to just basically make sure that one of these standards have not changed. Otherwise, I will be running into some issues. Okay. Right. That's where I made the mistake. Close this, close this. This is done. Okay. 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 Yes. Formatting will look. Yeah. Spelling error. Now I'll just quickly check what's happening on the website with my own blockchain explorer. It should show all the transactions that are getting deployed on these or sort of running on these blockchains. And you'll be able to figure it out what's happening, what will be happening. 99% is the same contract, but just going to confirm. Yeah. So as you'll see, a contract that says lock with 1 ether and unlock timestamp, so and so deployed to this exact address, right? And it's 3829 and ends with E50. And if I go to Billware, it is basically over here, contract created. And if I click this, it'll open that particular transaction and the contract is deployed. And the address is 0x38, ends with E50. And this particular is now a deployment actually on a testnet. And I can send across this to anyone to anyone. And essentially, if I verify this contract real quick, I'll be basically opening up people to play around with this particular contract. And just to close the loop over here, what I'm going to do is I'm just going to go to contract. Now, verification has its own procedure, how it is done and everything. It's a different one, which we will go through tomorrow. But for today's, what I'm going to just do is contract, copy paste what we call the ABI of this particular contract. ABI is basically the interface of this particular contract through which JavaScript, we can use JavaScript to interact with this contract. So I'm just going to go paste it inside and see if I've just copied everything correctly. Then it should basically say it worked. Right now, as you see, this contract now has my unlocked account as its owner. It has its unique timestamp, which is the unlock time. As I was talking about, since these are public variables, you can easily read them. And if I have to just say write contract, there's only one function, withdraw, which I can now interact with. Now, if I were to do this transaction using my MetaMask account, it will fail. So we're going to try and do that real quick. Obviously says that you're on a different network. So I'm going to basically convert this to add the network to my MetaMask to be playing with the same network. Just say approve, switch network, and it should now be the correct network. I'll quickly check that on my MetaMask. Whatever, doesn't matter. Yeah, cool. Okay, and just changing the account, which has some value. Which is account 1. It has so much native token, and I'm going to call the write functionality. It'll fail for various reasons, as you see. First of all, this is just failing. Wait, just quickly refreshing this page because it's changing for completely different reasons. Right. Right. Just quickly pasting this API again, so then I'm able to interact with that. Network 3, right. Now, once I clicked the write function, what's really happening is that our MetaMask pop-up is coming so that it interacts with the blockchain. And I'm going to confirm this. And you'll see it failed, right? And if I click this, it will show me only the failure. Unfortunately, it has its own issues if the contract is not verified. But in this case, we see that I cannot withdraw it yet. Obviously, because when I created this contract, I said that the lock time is going to be for 1 year. Now, how we're going to test it with 1 year or not, I think that's a different thing. Again, we're going to talk about it in tomorrow's session, but you're now able to see that how you're able to test it at a public chain level. Right. So that's it for today. We're going to go through some complicated contracts tomorrow, some of the complicated scripts tomorrow, some of the complicated functions tomorrow. And obviously, we're going to share across these presentation again that has links to sort of everything that I've just talked about, as well as the link to the GitHub repository that I'm going to go through tomorrow. So if more than happy, more than feel free to go through that code base, play around with it before the session tomorrow. Come with a lot of questions, and we'll try to go through all of them and resolve them. Right. I have just one last question from Gaming Theory. It says, why do we have to use memory keyword for accepting string argument or return? Okay. So in some of the previous versions of Solidity, if I'm not wrong, like 0.6, 0. And before, we didn't have this requirement. Now, unfortunately, to play around with blockchain, there are certain distinction of where variables or values of those variables are stored inside the blockchain. Memory being one slot, storage being the other slot, so on and so forth. And that brought about the reason that when you are basically sometimes overlaying the same variable names, you have to just define where it's located. And that's how that was one of the reasons why we had to define memory, that the value of this variable is inside the memory of the processing of the function, but not inside the storage of the contract itself. Sometimes we actually also use storage when we have to return the value which is inside the storage of aspect of the contract. Right. I hope that sort of addresses everything, or is simple enough for today. Feel free to make mistakes, run these transactions, do stuff again, go to Remix, probably play around with it, do as much as you want to, just make mistakes, because that's what important it is for you at this stage, and to people to understand how to process things. Cool. Thank you again, guys, for tuning in. I will be continuing with my session tomorrow on advanced topics for the smart contracts. And yeah, we'll see you tomorrow again. Ciao.